Hi, I'm Alfred. I'm a part of Sydney Group 20, and today I'll be doing the presentation for the assessment too. So the objective of the assessment is to derive meaningful insight from the given datasets on of how digital screen time affects this well-being. Uh, so we are provided with three datasets. So the approach is that we just combine. For doing the first part of the assessment, I'll be doing the descriptive statistics analysis one using the datasets 2 and 3. We'll just combine the datasets, wrangle this, clean the data, uh, calculate and compare different relevant statistics measures and analyze the results. So jumping onto the coding part of the assessment, uh, Pandas is mainly used for this for the uh, for deriving outputs. So the modules required for first imported and the CSV file containing the data are then imported. It's then joined by using Pandas. Then the ID is removed so for the further analysis. Uh, Followed by the total screen time is just added upon. So as per the research of Australian Institute of Family Sciences, it's found that the optimal screen time for teenagers is 14 hours per week. So as per this report, we just divide our screen time data into four categories of low, moderate, high, and very high. So uh, the descriptive statistics measures for this thing calculated. Followed by the for the same for the well-being indicators. So we use the mean as the main descriptive statistics measure for the screen time data and median for the um, well-being data because it's ordinal. Followed by we just represent this data by using box plots, and these are the codes for it. So running these codes, uh, the use of box plots has a real significance here because it helps us to find outliers or underspread. Also, we can just understand how the data is distributed and if it's skewed or uh, not, and helps us to derive easy outputs. So moving on to the uh, exercise. So for the we just analyze by using the low and moderate and very high screen time categories. So the well-being scores were found to be an average level for the low screen time category, although there were some outliers for the moderate screen time and high screen time. Those were comparable, and for the very high screen time, the wellness scores were very low. So conclusion is that the digital screen time, it's always better to use have less digital screen time, but moderation is the key to success. um, and also since there's much outliers um, for the low screen time category, this observation can be found. So the second analysis for the second analysis, the results 1 and 3 can be used. The methods are used almost the same for the first method. So this data analysis compares the demographies with the well-being scores. So my friend Jibin will be taking over the part from here. Thank you.
Hi, my name is Divin Jeju. I'm going to explain about the descriptive static analysis that I use by on the combined dataset of 1 and dataset 3. This is the approach we done. Let's dive into the code. First, we read the dataset and merge using inner join, and we fill out the missing values, and we extract the columns. After that, we calculate the tendency, mean, and mode for the well-being indicator on the base of demographic categories, and we save them into an CSV file. Same as we also did a box plot on the basis of demographic categories, uh, and we save them into a image file as well. Now let's run the code. This is the first where we done the classification on the basis of the gender, male and female, on the well-being indicator. The next would be based on the minority status on the well-being indicator. The next is the deprivation status. on the basis of well-being indicator. Well-being indicator on the basis of, okay, anyway. Now, from this box plot, we can infer that there is a minimal variation in the well-being indicators between the three demographic groups: deprivation status, gender, and minority status. So we can say that there is no clear distinction between the groups, and the median and the interquartile range are very similar across the demographic groups for all the well-being indicators, meaning that the well-being is generally consistent regardless of the demographic factors. So we can conclude that the demographic factors does not affect the well-being of the adolescents. Next, we use an inferential statistics on the combined dataset of dataset 2 and dataset 3. Our objective is to analysis and investigation whether a relationship between the screen time and various and the well-being indicators exist or not. This is our approach. Let's dive into the code. First, we combine the dataset. First, we read the dataset and combine them using inner join. Then we calculate. Then we extracted the well columns for the screen time column and the well-being column. Then we divide it into 4 bins. The value was chosen because by well-health organization, the optimal screen time for an adolescent is less than 14. That's why we group this. Then we calculated the f-statistics p-value for each bins and store them into CSV file. Now we just run that. We'll run and we'll get value. Yeah, we have it. For from this, we can say that none of the well-being indicators are significant with the screen time usage. So based on the CSV result, we can say that the most p-value are greater than 0.0038, meaning there are no statistically significant difference between the screen time group for most well-being indicators. For example, the F statistics for optimism is relatively low and the p-value is above the threshold, no significance. Similarly, the rest of the well-being indicators is similar. From this, we can conclude that the screen time does not significantly affect the well-being indicators in the dataset.
Parental statistics. First, we performed a t-test on optimism. We performed a t-test to compare optimism between high and low screen time groups. We split the respondents into two groups based on their total screen time. The t-test result showed a significant difference with the low screen time group, reporting much higher optimism score. The p-value was extremely small, indicating strong statistical significance. Here we find that t statistics on optimism is minus 19.91 and p-value is 5.28, 10 to the power minus 88. That means significant difference in optimism with low screen time groups reported higher score. We performed another t-test on feeling useful to compare how useful respondents felt between high and low screen time groups. Again, the low screen time groups reported significantly higher score. The p-value here was also extremely small and indicating that the difference is statistically significant. Significant. Here we find that t statistics is minus 30.81 and p below 2.13 to 10 to the minus 207. Here we also are on the t-test result. It indicates that low screen time groups consistently have higher well-being score, and this suggests that the limited screen time could have a positive impact on well-being. And our analysis show that higher screen time is associated with lower well-being score. The most significant difference were found in optimism and feeling useful, where the low screen time groups consistently reported higher score. This has important implication for adolescents, as reducing screen time could lead to better mental health outcome. Now I will show the code for my part. This is the part for identifying the mean and standard deviation. First, we merge the data and refining high and low screen time groups based on median screen time. from different week and then divided into high and low screen time groups, and we also calculate the mean screen time by gender and minority status. Now I will run. Here we find the mean and standard deviation. This is the raw file of this code, and here we also redefining high and low screen time groups based on median score, and we also divided into high and low screen time groups and perform t-test on optimism and feeling useful, and we also show the t-test result. Now I will run this code. Yeah, here we can see the difference between well-being score and high and low screen time groups. Thank you.